Now in this topic we are going to prove the refraction and reflection of plane waves by using Huygen's principle. Now we are only considering of plane waves. So let's say this is a wavefront. This is a plane wavefront. Now this is my incident wavefront. This is my incident wavefront. Okay. So now say suppose it's striking this surface. Say this is my surface. Let me draw this surface and let me extend the surface. So this is my surface. Let this be medium 1. This part from where the incident wavefront is coming be medium 1. Medium 1. And from this separation to downward, let this be medium 2. This is medium 2. So now this part, that is, say suppose let's name this as A and B. So this part, this is A, so this will be A dash, and let's say this part be B, this part be, let's say, D. So now this B has yet to come, but A has already strike the separation medium. So a distance of, say this is the distance left, this is the distance left for this to strike. So let this point be C, this point be C. So now my question is, what is this length BC? So now when waves are concerned, there will be a speed. So let the speed of this wavefront in medium 1 be speed be v1. So what we are taking v1, we are taking the speed of wavefront in medium 1. Similarly, let's define v2 as speed of wavefront in medium 2. In medium 2. Okay. So now let the time taken for this wavefront to reach this be time t, or say tau. So let this be time tau. This is my time t. This is my time to reach over here to here. So the distance is given by velocity into time, or speed into time. So this particular distance, when you talk about this distance, is v1 into tau. So this is a distance, and this makes an angle of 90 degree. Let me know, this makes an angle of 90 degree. So now, if I draw a normal at the point of incidence, what I will see is this angle is my, say, I. So if this angle is I, then definitely this angle will also be I by geometry, that is by triangles. So why? Because if you draw this, if I draw this line, this will be this angle I. Now whatever this angle, if I extend this line, this angle will be an angle of refraction. Now this is angle of refraction. So angle of refraction, let's denote this by this green color, that is R. So what is this R? If this is angle of incidence, this will be angle of refraction. So let this be somewhere over here. after that, let's join these 2 points. Let's join these 2 points. This is my point C. Let's join this. Okay, so we have joined. So what is this length? What is this length? This length is nothing but your time taken to reach from here to here. That is velocity of this wave for time interval of tau. That is t. So far we have defined all the necessary quantities that we will need. So if this is angle R, this is also angle R. The angle of refracted wavefront. This is the refracted wavefront. So what is this? This is the incident wavefront and this is the refracted wavefront. Refracted wavefront. So this is all that we need. Now if you look at this particular diagram and if we start doing our calculation, then our calculation would be in this way. Let's have a look. Now after defining all of these quantities, what we have is, if you look at sine I. Now please keep in mind this is making a right angle triangle. This is making a right angle triangle. Therefore sine I is nothing but your BC. What was the BC? This is BC. So this is a perpendicular. BC is a perpendicular. We know if this is theta. So if this is P, this is B and this is H. So sine theta is equal to perpendicular by base. So sine I, this is angle I, this is its perpendicular. Perpendicular upon hypotenuse. So this is BC, this line, this is point B. So B to C. So BC is BC upon AC, which is equal to, what was BC? This was V1 into tau. This was V1 into tau by AC. This is by AC. Now if you look at the refracted angle R, so this angle is equal to this angle, to R. So now if you look at R, what you will have is sine of R. This is sine of R. Again, this is perpendicular upon hypotenuse. This is perpendicular upon hypotenuse. So this is given by, what is this? Let this be AE. AE. So sine is AE upon the hypotenuse, that is AC, which is equal to V2 tau upon AC. Now, what is I angle was the angle of incidence and R is the angle of refraction respectively. So if you take sine I by sine R, say suppose this is equation 1 and this is equation 2. So if you take sine I upon sine R, what you have, AC and AC gets cancelled and tau gets cancelled. So V1 upon V2. So you get this V1 upon V2. Now what is V1 upon V2? We know what is, if we are talking about the refractive index of medium 1 with respect to refractive index of medium 1, then we know speed of light into the velocity 1. If you are talking about refractive index of medium 2, we are talking about the speed of light into V2. So if I now look at this calculation, now come over to this part of your board. Now what about N2 upon N1? N2 upon N1 was my refractive index of medium 2 with respect to medium 1. So N2 upon N1, if I take N2 upon N1, this gives me C upon V2 by C upon V1, which is equal to N2 upon N1 is this. So N2 upon N1 is V1 upon V2. Therefore, V1 upon V2 can also be written as N2 upon N1. So this particular equation, that is sine I upon sine R, is written as refractive index of medium 2 with respect to medium 1, and this is nothing but your Snell's law or the law of refraction. Refraction. And this is how we can easily prove that the Huygen principle holds true for refraction and reflection.